Okay, and welcome back to part 2 of 2.1 trigonometric functions of acute angles. Cofunction, trigonometric function whose values for any argument are equal to the given function of the complementary angle. So anyways, sine and cosine are cofunctions since sine of A equals cosine of B. So it's one of those, if you know, say A is 40. If you know the value of sine of 40, then you're going to know the cosine value of 50 because they will be the same. So since angle A and B are complementary, we can say A plus B equals 90 or B equals 90 minus A. So here's another thing that you just may want to put on a note card, because I don't think it's going to be anywhere else. For any acute angle A, sine of A is going to be equal to cosine of 90 minus A, which will make it angle B. Or we can go the other way, saying cosine of A equals sine of 90 minus whatever A is. Same with secant and cosecant, and tangent and cotangent. These are all your co-functions. And if you can remember the co part, that everybody has to have a co, and in this case it is sine and cosine, secant and cosecant, tangent, cotangent. This is the only time this happens. Okay, please do not confuse this later when you're doing sine and cosine and you're going, oh, cosine and cosine, they're not, no. Okay, so here we go. It says write each function in terms of its cofunction. Assume that all angles in which an unknown appears are acute angles. And you guys go, okay. So cotangent of 73. Well, cotangent of 73 will equal tangent of 90. Let's start this one again. Cofunctions. Cotangent of A is equal to tangent of 90 minus A. And in this case, A is 73. So what we need to do is find out what this angle is. So 90 minus 73 gives us 17. So we can go with cotangent of 73 is equal to tangent of 17. That's what they're wanting you to do, is to write it in terms of its cofunction. So the answer on this one would be that tangent of 17. Next one, they threw a variable in here, but they said assume that all angles in which an unknown appears are acute, so we get to assume that this number is less than 70. So cosine of A is equal to sine of 90 minus A. Oops. So in our case, our A is, that's alpha, it's a Greek letter, but we're going to just use A because I don't do well with alphas, plus 20. So we have 90 minus the alpha plus 20. Distribute your negative sign, you get 90 minus alpha minus 20. And you do your little bit of math here, and you get 70 minus alpha. So we can claim that, let's bring this down, cosine of alpha plus 20 is equal to sine of 70 minus alpha. Because if I was to add these two together, we would get 90 degrees in some way, shape, or form. Okay, don't overthink this one, you guys. You just set these equal to each other, or plugging the one in, you get the A value, you plug it into the other one, get the other angle. Basically, we're looking for complementary angles. 73 plus 17, 90, complementary angles. Okay, so we've got some equations we'll have to solve for. Solving equations using cofunction identities. Identify the angles are acute and that the trig functions are cofunctions. Now, usually the book will tell you, assume that they are blah, blah, blah. It's the cofunctions you got to be careful for. They cannot put secant and cosine together. They are not cofunctions. Make an equation where the sum of the two angles is 90 and then solve the equation. So we got a couple more examples here. So on this one here, find one solution for each equation. Assume that all angles in which an unknown appears are acute angles. And we have unknowns on both of these. Since the cofunction, we're looking at going cofunction. Yep. And we already told that they are acute angles. So we have to do beta plus 10 plus 2 beta plus 20 equals 90, because we want to actually know what these angles are this time. Combine like terms. Beta plus 2 beta gives us 3 beta. 10 plus 20 is 30, plus 30 equals 90. Subtract the 30 from both sides, and you get 3 beta equals 60. Divide both sides by 3, and you get beta equals 20. Now this is not what they're looking for. They're asking for a solution, which means we need to know what these angles are. So easy thing, we have beta plus 10 equals 20 plus 10, which is equal to 30. The other one is 2 beta plus 20 gives us 2 times 20 plus 20, which gives us 40 plus 20, which is equal to 60. And 60 plus 30 equals 90, so we're good. We don't have some number out there that's not supposed to be there. So our angles are 30 and 60. Now you can always go back and rewrite saying secant of 30 equals a cosecant of 60. And we have found our one solution. Using cofunctions, this is the only solution we would have found. So, okay, next one. What I'd like you guys to do is to pause the video for, well, however long you need to. I want you to do this problem yourself, see if you come up with the answers, and then go to the answer or watch the video, whichever. Don't know where this came from. We got to get rid of it. All right, so let's see if you work this problem through. So cosine and sine, they are definitely cofunctions. These are good. And we've already been told to assume things. So that means 2 theta plus 50 plus 2 theta minus 20 must equal 90. Combine like terms, 2 theta and 2 theta gives us 4 theta. 50 minus 20 gives us 30, so plus 30 equals 90. Subtract 30, subtract 30. 4 theta equals 60. Divide by 4, and we get theta equals 15. Again, that's not what we're looking for. We want the angles. So 2 times 15 plus 50 will give us 30 plus 50, which equals 80. And 2 times 15 minus 20 equals 30 minus 20 equals 10. And 80 plus 10 is 90. So again, we can rewrite it as cosine of 80 equals the sine of 10. So I'm going to go ahead and put this up here, the 2 theta plus 50, and on this one, this was 2 theta minus 20. Okay, and this is, I believe, the end of this. There it is. There's the homework that you should have already started on because it would have been listed under part 1 video.